Somewhere on Earth right now, water is moving through a riverbed older than any mountain you have ever seen. Before we go any further, if you want a brand new Earth topic every single night to fall asleep to, subscribe. One tap and a new story is waiting for you every evening. That same water has been falling, gathering, and flowing for an unimaginable stretch of time, slipping between stones that watched the first forests rise and fall. Tonight, we are going to drift along the long, quiet story of rivers, and we are going to sit with a question that science has never fully answered. How old, truly, is the water in a river? Picture the planet from far above, a soft blue sphere wrapped in slow white clouds. From that height, the continents look like worn pieces of old leather, and across each one, fine silver threads catch the light. Those threads are rivers. They branch and braid and pour toward the sea in patterns that look almost alive. Some of them are short and bright. Others curl across whole continents like sleeping snakes, and every one of them is carrying water that has been somewhere else before. The water in your nearest river has lived many lives. It has been ocean. It has been cloud. It has been rain falling on a forest you will never visit. It has been frost on a high mountain, ice in a deep glacier, mist on a quiet morning lake. The same molecules of water have moved through this loop for billions of years. Scientists who study the water cycle believe that most of the water on Earth is nearly as old as the planet itself. It's around 4.5 billion years old, older than the moon, older than the continents in their current shapes, older than the very idea of a river. And yet, no one is quite sure where all of this water came from in the first place. One theory says it arrived with icy comets, slowly bombarding the young Earth across long ages. Another theory says it was already here, locked inside the rocks of the early planet, then slowly released by volcanoes that hissed steam into the early sky. A third idea, gentler still, suggests that the water came from both sources, mixing together over hundreds of millions of years. The evidence is incomplete. The question remains open. Every river you see, in some sense, carries an unsolved mystery in its current. Imagine the first rain that ever fell on the bare young Earth. The land was hot, dark, and lifeless. Steam poured from cracks in the crust, and then, after enough cooling, the sky finally let go. Rain fell for what may have been thousands of years without stopping. That rain pooled into the first oceans. It traced the first channels into the first stone. Somewhere in that ancient downpour, the very first river was born. We do not know where it ran. We do not know its shape. But every river since has been, in a way, a memory of that one. Now soften your gaze and think of a single river you have seen in your life. Maybe a wide, slow brown river under a summer sky. Maybe a small mountain creek glittering between mossy rocks. Maybe a great gray ribbon seen from an airplane window, winding through farmland far below. That river has a hidden history. The pebbles in its bed were carried from somewhere upstream, perhaps from a cliff that no longer exists. The shape of its banks holds the record of old floods, old droughts, old winters when ice locked everything in place. A river is not just water moving downhill. It is a long, patient archive. Geologists like to say that rivers are among the oldest features on the land, and also among the youngest. Old, because the act of water flowing toward the sea has been happening for nearly the entire age of the Earth. Young because any single river constantly remakes itself, shifting its channel, swallowing islands, leaving new ones behind. The river you crossed as a child is not exactly the river that is there today, and yet it is, somehow, the same river. That quiet paradox is part of what we will wonder about together tonight. So let your shoulders soften, let your breathing slow. We are going to follow the long, sleepy thread of moving water across deep time. Past lost deserts, past drowned valleys, past stone tools left on banks that vanished long ago. And through it all, we will sit gently with a question that the science has not yet closed. What do rivers truly remember? A river, in the simplest words, is just water moving downhill. That is the whole secret of it. Rain falls, snow melts, springs leak up from underground, and gravity does the rest. The water finds the lowest place it can, then the next lowest, then the next. Over time, this slow searching becomes a path, and the path, given enough years, becomes a river. But the path is rarely straight. If you look down at a river from high above, you will see it bending and looping like a long ribbon dropped on a table. Each bend is the result of countless small choices the water has made. Soft soil washes away faster than hard rock. A fallen tree nudges the current, a pebble shifts. The river leans into the easier ground and leaves the harder ground behind. This is how, drop by drop, water cuts into stone. The cutting is patient. A river may lower its bed by only a fraction of an inch in a human lifetime. Yet given 1,000,000 years, that same river can carve a canyon hundreds of feet deep. Given 10 million, it can slice through mountains. The Colorado River in the American Southwest has been working on the Grand Canyon for somewhere between 5 and 70 million years, depending on which researchers you ask. The exact age of that great cut is still debated. Some studies suggest the canyon is young, sculpted in the last 6 million years. Others point to evidence of much older channels that the modern river simply found and deepened. The question of when the canyon truly began remains open. Rivers carry more than water. They carry sand, silt, gravel, dissolved minerals, leaves, logs, and tiny grains of clay. This load is what gives a river its real power. Pure water alone would scratch at the stone very gently, but water filled with grit becomes a slow, endless sandpaper. The Mississippi River, on an average day, carries enough sediment to fill several hundred train cars. The Yellow River in China carries so much pale yellow silt that the water itself looks like soft mustard, and that silt is where the river gets its name. When a river slows down, it drops what it has been carrying. This is how floodplains form. A floodplain is the flat land on either side of a river where, every so often, the water spreads out and lays down a thin new layer of mud. Each layer is rich in minerals. This is why so many of the world's oldest farms and so many of the world's oldest cities sit on river floodplains. The soil there is some of the most generous on Earth, and it is the river itself that made it. The bend of a river has a name. It is called a meander, from an old river in what is now Turkey, whose curves were so famous that the word entered many languages. The meander grows slowly outward as the current pushes against the outer bank and deposits sand on the inner bank. After enough centuries, the loop can become so tight that the river cuts across its own neck, and leaves the old bend behind as a curved pond. These ponds are called oxbow lakes. From the air, an old floodplain can look scattered with the ghosts of past channels, like a long memory written in water. Most rivers are not very deep. Even the great ones, the Amazon, the Congo, the Mekong, are usually only a few dozen feet deep in most places. The Amazon has some channels that drop more than 200 feet, deeper than a 20-story building. But across most of its length, it would barely cover a small house. A river's power comes less from its depth and more from its length, its volume, and the patience of its work. How long has any of this been going on? That is one of the quiet questions in the study of rivers. Some river systems are young, only a few thousand years old, born from melting glaciers at the end of the last ice age. Others may have been flowing in some form for hundreds of millions of years, changing course many times but never quite vanishing. Telling the two apart is harder than it sounds. A river leaves few clear records of its own past. It erases itself as it goes. So this is what a river is in the simplest terms: water moving downhill. Sand and silt and patience. A slow, bending path through soft places and hard places alike. And underneath every river we can see today, there is almost certainly an older river we cannot. That is where the real mystery begins. Beneath the dry sands of the Sahara, something old is sleeping. Hidden under dunes that stretch farther than the eye can see, there are riverbeds, long, winding channels carved into the bedrock. Some are wider than the Nile, some run for hundreds of miles, and not one of them holds water today. To understand how this came to be, we need to travel back in time, not just a few centuries, but tens of thousands of years. The Sahara we picture now, that ocean of golden sand and bone-dry rock, is only one face of a place that has worn many faces. There were long stretches when the Sahara was green. Grasslands rolled across what is now sand. Lakes shimmered where caravans now cross. And rivers, real rivers, full and flowing, carved the land. Scientists call these wet stretches the African humid periods. The last one ended somewhere around 5,000 or 6,000 years ago. Before that, for thousands of years, monsoon rains pushed far north into the continent. The skies opened over land that today sees almost no rain at all. Grass grew, trees rooted, animals came. And the rivers ran. How did this happen? One leading idea points to the slow wobble of Earth itself. Our planet does not spin perfectly upright. Its tilt and the shape of its orbit shift over very long cycles, sometimes called Milankovitch cycles after the researcher who first described them. These small changes alter how much sunlight reaches different parts of the world in different seasons. When the northern summers grow warmer, the monsoon belt can drift north. Rain falls where it has not fallen for ages. The desert blooms. That is one theory, and it fits much of the evidence. But the full story is still being pieced together. Some researchers wonder whether vegetation itself helped pull the rains farther in. The green land feeding back into the climate in ways we do not yet fully model. Others ask why the change at the end of the green Sahara seems to have come so quickly, almost as if a switch flipped. The transition from grassland to desert may have taken only a few centuries. That is fast, geologically speaking, and the reason remains an open question. What is not in question are the rivers themselves. Satellite radar, the kind that can see a short way under dry sand, has revealed the ghostly outlines of huge ancient channels. One of the largest, sometimes called the Tamanrasset, once drained a vast area of what is now Western Africa. It flowed for perhaps 1,000 miles before reaching the Atlantic. In its day, it would have ranked among the great rivers of the world. Today, almost nothing of it shows on the surface, just faint hollows in the dunes and the slow memory held in the rock below. Along the banks of these vanished rivers, people lived. Archaeologists have found their fishing hooks carved from bone. They have found harpoons, grinding stones, and the small remains of meals long eaten. They have found rock art tucked into shaded cliffs, painted figures of cattle, of swimmers, of long-horned creatures grazing in herds. The art is calm and patient, the way you might draw something you saw every day. To those who painted it, the green Sahara was simply home. How the rivers themselves were born is its own quiet puzzle. Some likely followed older cracks and weak lines in the bedrock, paths laid down long before the most recent wet period. Others may have been carved freshly, season by season, as monsoon floods reshaped the land. The rivers we see traces of today are probably layered systems, ancient courses reused again and again whenever the rains returned. Each green period wrote a new chapter on top of the last. The desert preserved them all. What ended the rivers is the same wobble in reverse. The orbital tilt shifted again. The monsoon belt drifted south. The rains thinned. The lakes shrank. The grass died back. The rivers ran lower each year, then ran only in flood, then ran no more. The wind began its long, patient work of covering everything in sand. The fishing villages emptied. The painted cliffs grew quiet. The channels became memories carved in stone. We can still ask what we do not know. Why did the green periods come when they did, and not in other warm times? How often, across the deep past, has the Sahara been wet? Some evidence suggests this cycle has repeated for millions of years, again and again, a slow breathing of the desert. But the rhythm is not yet fully understood. The lost rivers wait beneath the dunes, holding their answers, while the wind moves softly above them in the dark. Far below the surface of the sea, in places where no sunlight reaches, the ocean floor remembers rivers. Long grooves run across the muddy bottom. Wide channels twist and bend like the rivers we know on land. Some are buried under thick layers of sediment. Others lie open, their shapes carved into the seabed as clearly as a path through a forest. These are the ancient channels beneath the sea, and the question of what carved them has occupied geologists for many quiet decades. Some of these underwater channels began as true rivers long ago, when sea levels were much lower. During the Great Ice Ages, vast amounts of water were locked into glaciers. The shoreline stood far out beyond where they sit today. Rivers that now end at the coast once flowed many miles further, cutting deep valleys into what is now seabed. When the ice melted, the ocean rose and drowned those valleys. The rivers vanished, but their old paths remained, hidden under cold green water. Other underwater channels were carved by something stranger. Beneath the waves, dense rivers of mud and sand sometimes flow downhill along the ocean floor. These are called turbidity currents, and they are made of the same materials as the seabed itself. only stirred up and heavy with suspended grains. A turbidity current can run for hundreds of miles. It can move faster than a person can walk, and it can cut channels into solid rock. We rarely see them happen. We mostly see what they leave behind. The materials inside these hidden flows tell a long story. Each grain of sand began as part of a mountain. Wind and rain broke the mountain down. Surface rivers carried the pieces toward the sea. Quartz, the most common mineral in river sand, is made of silicon and oxygen, two of the most plentiful elements in the Earth's crust. The iron that gives some river muds their rusty color was forged inside ancient stars, long before the Earth existed, and scattered across space when those stars died. Every reddish streak in a river bank carries a faint memory of stellar fire. The water itself carries an even older mystery. Some researchers think much of Earth's water arrived on icy comets and asteroids during the planet's early years. Others think the water was already here, locked inside the rocks that came together to form the young Earth, and slowly released through volcanoes over billions of years. The truth may be a mix of both. The question remains open. Whatever its source, that same water now drifts through underwater canyons, dark and slow, carrying minerals from one continent toward another. The mud that settles inside these deep channels is a quiet library. It holds tiny shells from creatures that lived near the surface and drifted down after they died. It holds grains of pollen from forests on faraway shores. It holds flakes of clay so small that millions could fit on a fingernail. The clay is made mostly of aluminum, silicon, and oxygen, bound together in delicate layered sheets. Each sheet was built by slow chemical work, water acting on stone, over thousands or millions of years. The seabed channels are stitched together from this patient material. Some of the most studied submarine channels lie off the mouths of great rivers. Beyond the Congo, a deep canyon cuts into the African shelf and runs far out into the Atlantic. Beyond the Ganges, an enormous fan of sediment spreads across the floor of the Bay of Bengal. These features are vast, larger than many land rivers, yet they sit in complete darkness. We map them with sound, sending pulses down and listening for the echoes. The maps grow clearer each year, and yet the deeper questions stay unsettled. How often do the channels run? What triggers them? Whether earthquakes, storms, or simply the slow piling of sediment until it gives way. There is one idea worth sitting with as you rest. The materials moving through these dark underwater rivers are the same materials that built the continents. Quartz, feldspar, clay, the bones of small sea creatures, the iron from old stars. Mountains rise, rain breaks them down, rivers carry them to the sea, underwater currents pull them further still into the deep. In time, those grains may be pressed back into stone, lifted again by the slow movement of the crust, and weathered once more. The same atoms travel the same long loop, over and over. We do not fully understand how often these hidden channels stir, or how much of the seafloor they shape. The deep ocean keeps most of its work to itself. For now, the channels run quietly in the dark, carrying old mountains toward older basins, and the question of their full story remains open. Rivers seem to obey one simple rule: water runs downhill, from the high places to the low places, always without fail. And yet, when we look closely at the long history of rivers on Earth, that simple rule starts to bend in strange ways. Some rivers, it seems, once flowed in the opposite direction. The land beneath them tilted, lifted, sank, or buckled, and the water followed a new slope toward a new sea. The old course faded into dry stone, leaving only quiet hints behind. To understand how this can happen, it helps to picture the forces that work on a river over deep time. Gravity is the first and most patient force. It pulls every drop of water toward the lowest point it can find, but the ground itself is not still. Beneath our feet, the crust of the earth moves in slow, steady ways. Hot rock deep in the mantle pushes upward in some places and sinks in others. Whole regions can rise by tiny amounts each year. Over millions of years, those tiny amounts add up to mountains. When the land rises in one place, the slope of a river changes. A gentle tilt that once sent water east may, over a vast stretch of time, turn into a tilt that sends water west. The river does not notice. It simply follows the new low ground. Pebbles that once traveled toward one ocean begin, in the next chapter, to travel toward another. The river has reversed. One of the most discussed examples is the Amazon. Today, the Amazon runs east, across the wide green heart of South America, toward the Atlantic. But there is evidence in the old sands and gravels of the continent that suggests the river, or its ancestors, once flowed the other way. Some researchers believe that long ago, before the Andes rose along the western edge of the continent, water drained westward toward what is now the Pacific. When the great mountain wall slowly lifted, it blocked that old path. Water pooled in vast inland basins. Eventually, the rising land tilted the whole system the other way, and the Amazon turned to face the rising sun. That is one theory. Other researchers wonder if the story was more tangled than a single neat reversal. Perhaps the ancient water moved north for a time, into a shallow sea that once cut across the continent. Perhaps the reversal happened in stages, with long pauses and false starts. The grains of sand locked inside ancient rock layers carry tiny clues, but the clues are incomplete. Each new study adjusts the picture a little. Other forces also shape these slow reversals. The weight of ice can press a continent down by hundreds of meters. When the ice melts, the land slowly rises again, sometimes for thousands of years after the glaciers are gone. This rebound can tilt rivers in surprising ways. In parts of northern Europe and North America, the land is still lifting today, recovering from the great ice sheets that vanished long ago. Streams that drained one way during the ice may now drain another way, and the change is still in progress. Pressure from colliding continents also bends the path of rivers. When two slabs of crust press against each other, mountains rise along the seam. The land on either side warps. Old river valleys can be lifted high, leaving dry gravel beds perched on hillsides far above any modern stream. These ghost valleys are quiet evidence of currents that no longer flow. Heat plays its part as well. Deep beneath certain regions, plumes of warm rock push the crust upward into broad, gentle domes. A dome of this kind can take millions of years to grow. As it grows, the rivers on its flanks slide outward, away from the high center. A river that once crossed the dome may be split, redirected, or reversed entirely. What makes all of this so soothing to think about is the patience of it. No single storm reverses a river. No single earthquake flips a current. It is the long, slow accumulation of small movements, repeated across millions of mornings and evenings, that slowly turns the water around. The river itself never struggles. It simply listens to the ground and follows whichever way is lower today. How many rivers, then, have quietly reversed across the long ages of the earth? We do not really know. Each continent likely holds dozens of such stories, most of them only half-read. The evidence sits in old gravels, in tilted layers, in the chemistry of tiny grains. The mystery of reversed currents remains open, waiting in the patient stone, while the rivers we know keep flowing in the only direction that, for now, makes sense to them. Picture the scale of a city, not a modern city of glass and steel, but one of the very first. Around 6,000 years ago, in the warm, flat country between two long rivers, people began to gather in numbers no one had ever gathered in before. The place was called Uruk, and it sat near the slow brown waters of the Euphrates. At its peak, Uruk may have held 50 or 60,000 people inside a mud brick wall. That sounds modest today, but for its time, it was almost beyond imagining. Try to feel the size of that gathering. If you took every person you have ever spoken to in your life, every face you remember, every neighbor, every stranger at every store, you would likely fall short of 50,000. Uruk packed all of those people into about 2.5 square miles. That is roughly the size of a small airport. And surrounding it, the river plain stretched flat and shining for hundreds of miles in every direction, lined with reeds taller than a person. The two rivers that fed this first great city, the Tigris and the Euphrates, are long by human standards but small by the planet's. Each runs about 1,100 to 1,700 miles from its mountain source to the sea. If you laid one of them along the eastern coast of the United States, it would reach from Florida to Maine. Yet compared to the Nile, or the Amazon, or the great frozen rivers of Siberia, these two rivers are middle-sized at best. It is humbling to think that all of early urban life, all of writing, all of the first laws and first taxes, grew along the banks of what are, in planetary terms, modest streams. The mystery sits in the question of why these rivers and not others. There were dozens of rivers across the warm latitudes where cities could have begun. Some were larger, some were calmer, yet the first true cities seemed to cluster along just a few. The Tigris and Euphrates in Mesopotamia, the Nile in Egypt, the Indus and the now vanished Saraswati in South Asia, the Yellow River in China, 5 river systems, give or take, out of all the world's rivers, 5. One theory is that these rivers offered a rare mix of qualities: predictable flooding, which laid down fresh black silt every year, flat ground for irrigation, a dry climate around the river that pushed people toward its banks rather than spreading them across the land. Other rivers had some of these things, but not all together. The combination, this idea suggests, was the spark. A different theory points to something less measurable. Some researchers wonder whether the rise of cities had less to do with the rivers themselves and more to do with what the people brought with them. Ideas, crops, animals, a willingness to live shoulder to shoulder. The rivers, in this view, were the stage, but the play could have been performed elsewhere. We may never know which view is closer to the truth, because the earliest layers of these settlements lie buried under thousands of years of newer mud. Think of the depth of that mud. At some ancient sites, the original ground level of the first village sits 60 or 70 feet below the modern surface. That is the height of a six-story building, made entirely of the crushed remains of older lives. Walls knocked down, rebuilt, knocked down again. Floors swept smooth, then covered by floors swept smooth on top of them. The rivers laid down silt, the people laid down stories, and the layers piled up. The time scale is the part that is hardest to feel. Uruk's earliest temples may date to around 4000 BCE. That is 6,000 years ago. If you took every year of your own life and stacked it up, you would need 80 or 100 lifetimes laid end to end just to reach back to the building of those first walls. And the river itself was already old. The Euphrates had been flowing in roughly its present path for millions of years before the first brick was ever pressed. So the river is the patient one. It was there before the city. It will be there after. The city flickered into being for a few thousand years, glowed, and then faded into mounds of soft earth that travelers now mistake for natural hills. Why these rivers became cradles, and not the hundreds of others, remains one of the gentle puzzles of human prehistory. The water keeps its silence, the silt keeps its secrets, and somewhere beneath the modern fields of southern Iraq, the first streets of the first city lie quiet, waiting for questions no one has yet thought to ask. Imagine floating high above the eastern half of Africa, looking down through a soft layer of morning haze. Below you, a thin ribbon of silver winds north across the land. It cuts through deserts the color of pale gold, past green strips of farmland, through old cities of mud brick and stone. The ribbon is the Nile, the longest river on Earth. And from this height, it looks almost like a long, slow vein drawn across the face of a continent. Lower yourself in your imagination down to the river itself. The water is wide and calm. Its surface holds the color of the sky above it, a soft blue in the morning, a warm gold near sunset, a deep violet just before the stars come out. Tall reeds line the banks in places. Date palms lean toward the water. Small boats with white sails drift slowly along, leaving thin trails in the current. If you follow the river south against its flow, the land begins to change. The narrow green strip widens. Marshes appear, vast and shimmering, full of birds with long, thin legs. This is the Sud, a great wetland in South Sudan, where the river spreads itself thin across flat ground and seems, for a while, to forget where it is going. Papyrus plants grow thick here, soft green stalks topped with feathery crowns. The water moves so slowly that in places it barely seems to move at all. Keep going south and the land lifts, hills rise. The river splits into branches. One branch leads to a great lake, a freshwater sea so wide you cannot see across it, ringed by green hills and small fishing villages. This is Lake Victoria, often called the source of the Nile, but this name carries a quiet mystery. Lake Victoria is fed by other rivers, and those rivers are fed by smaller streams, and those streams are fed by springs and rains that fall on highlands far to the south and west. So where truly does the Nile begin? For thousands of years, people wondered about this. Ancient Egyptian writers spoke of the river coming from a hidden land beyond the southern mountains. Greek travelers tried to follow it and turned back, defeated by the marshes and the heat. Arab geographers drew maps with a great inland lake, fed by snow-covered peaks they called the Mountains of the Moon. European explorers in the 1800s argued bitterly over which lake, which stream, which spring deserved the title of true source. Even today, the question is not fully settled. Some researchers point to a small spring in the highlands of Rwanda or Burundi, deep in the forests, where a thin trickle of water emerges from the earth and begins its long journey north. Others argue that the true source lies in Ethiopia, where the Blue Nile pours out of Lake Tana and crashes down through deep gorges before joining the main river in Sudan. The Blue Nile carries most of the water and most of the rich, dark silt that once flooded the fields of ancient Egypt every summer. Without it, the Nile we know would not exist, so the question becomes a quiet puzzle. Is the source the farthest trickle, or the lake that gathers the most water, or the branch that gives the river its life-giving mud? Different answers feel right for different reasons. The mystery is not really about geography. It is about how we choose to define a beginning. From above, you can see all of it at once. The pale spring in the green forest, the streams gathering into rivers, the rivers gathering into lakes, the lakes pouring into the great trunk that flows north, the marshes where the water hesitates, the desert where the river becomes the only living thing for hundreds of miles, the delta where it finally fans out into the Mediterranean Sea, splitting into many fingers of water before disappearing into salt. There is something soothing about watching a river from this height, the slow curves, the patient flow. The way it has shaped the land beneath it over millions of years, carving a long, shallow valley through stone and sand. The Nile has been flowing, in some form, for a very long time. Some geologists believe its present path is only a few million years old. Others suggest much older rivers ran across this same region, fading and reappearing as the climate changed. The water below you keeps moving. It does not care which spring we choose to call its first. It simply flows as it has always flowed, from many small beginnings toward one great ending. And we, looking down from above, are left with the soft, open question of where, exactly, a river truly begins. Some rivers, when you look at them today, run in a direction they did not always favor. The land tilts one way now, but long ago it tilted another, and the water followed the older slope. To imagine this is to imagine a world where the map of flowing water looked nothing like the one we know. And it is one of the quieter mysteries of deep time, written into riverbeds that have outlived the mountains that once shaped them. The clearest example may be the Amazon. Today it flows east, pouring an enormous volume of fresh water into the Atlantic. But for much of its long life, the Amazon basin appears to have drained the other way, toward the west, into what is now the foot of the Andes. The evidence sits in old sandstones, in the worn shapes of ancient pebbles, in the slow stories that grains of mineral can tell when scientists study them carefully. The pebbles came from the east, from old highlands that have since worn down to gentle hills. They were carried west by long-vanished currents, deposited in layers that geologists still read like patient pages. What changed everything, one theory suggests, was the slow rise of the Andes. As that great wall of stone pushed up from the edge of the South American plate, it blocked the old westward path. The water had nowhere to go on that side. It pooled, it spread. For long stretches of time, the central part of the continent may have held a vast wetland, a shallow inland sea of slow brown water and drifting plants. It's only later, when the eastern outlet finally opened, did the river turn around and begin its long journey toward the Atlantic. That is one possibility. Other researchers wonder whether the reversal happened in stages, with different sections turning at different times. The whole rearrangement spread across millions of years. Other rivers tell similar stories in quieter voices. In parts of North America, old channels point in directions that make no sense for the land as it sits today. In Central Africa, the Congo Basin seems to have once drained inland toward a great lake, before some shift of the land opened a path to the sea. In Asia, certain tributaries of the Ganges and the Brahmaputra appear to have switched allegiance long ago, abandoning one master river for another. The land breathes slowly, continents flex. What was downhill in one age becomes uphill in the next. And the water, patient as ever, simply finds the new low place and goes. To picture a reversed river, imagine standing on the bank of the Amazon at sunrise. The water is the color of weak tea, wide as a small sea, moving steadily east toward the rising sun. Now imagine the same place, but tens of millions of years earlier. The sun still rises in the east, but the river runs the other way, toward a horizon that holds no Andes yet, only low old hills and a soft western sky. The air smells of warm mud and unfamiliar plants. The fish in the water belong to species the world has since forgotten. Everything else feels almost the same, only the direction has changed. What remains unknown is the timing and the exact shape of the turn. Did the river slow to a stop somewhere in the middle, then begin to move the other way as the new slope took hold? Or did it split for a while, sending part of itself east and part of itself west, like a long argument with the land? The sediments give hints, but they are smudged and incomplete. Rocks that might hold the clearest answers have eroded away. Other rocks, still buried deep, have not yet been studied. The story is real, but its middle chapters are missing. There is something soothing in this idea if you let it settle. A river is not a fixed thing. It is a long agreement between water and stone, renewed each moment and sometimes renegotiated across ages. The river you see today is only the current draft of a much older document. Beneath it lie earlier versions, written in gravel and clay, pointing in directions the surface has forgotten. So as you rest, picture that older Amazon flowing westward through a green world without mountains. Picture the patient turn, slower than any human lifetime, as the land tilted and the water learned a new way home. The mystery of when and how quickly and how many times remains open. Geologists keep reading the rocks. The rivers keep flowing in whichever direction the land allows. And somewhere far below the surface, the old westward current sleeps on, remembered only in stone. Beneath the streets of many great cities, old rivers still flow. They run in the dark, hidden inside brick tunnels, slipping under sidewalks and subway lines. Long ago, these waters wound through open valleys fringed with reeds and willows. People drank from them. Children waded in them. Then the cities grew, and the rivers were covered over, one stone at a time. Now they are ghost streams, present but unseen, and they raise a quiet question that geologists and historians still puzzle over. The question is this: how many of these buried rivers are still doing their old work, deep below the pavement, shaping the city without anyone noticing? We know some are. Engineers find them when basements flood for no clear reason. Workers find them when a tunnel cuts through a soft seam of gravel and water pours in. The maps of these underground flows are still being drawn, and many remain incomplete. In London, a river called the Fleet once carried boats. Now it runs beneath the streets, hidden inside a sewer, joining the Thames through a small dark opening at low tide. In Paris, the Beaver once turned mills and dyed cloth. Today it lies under the city, sealed away in stone. In New York, small streams that once fed marshes still seep through the soil beneath skyscrapers, and they sometimes rise into subway tunnels during heavy rain. The list is long, and the pattern is everywhere old cities have grown. What makes these ghost streams so interesting is that they keep their rhythms. Rivers pulse with the seasons. They rise with spring melt, they fall in late summer, they swell after storms and rest in dry weeks. A river covered by concrete does not forget these cycles. The water still moves, the flow still climbs and ebbs. The buried stream breathes slowly, under the feet of millions of people who have no idea it is there. Some researchers wonder how much these hidden cycles still affect the cities above them. One idea is that the soft ground along old river paths settles differently than the firmer ground beside it. Buildings on those lines may shift by tiny amounts each year, following the slow pulse of the buried water. Another idea is that the wet seems along ghost streams shape where trees grow best in city parks, where certain plants thrive in cracks, where fog gathers on cool mornings. These ideas are hard to test in a tangled, busy city, and the evidence is still being gathered. There's also the question of what these streams carry. River water moves minerals, tiny grains, and the slow chemistry of the soil. When a stream is buried, that work does not stop. It only goes on in the dark, out of sight. Some scientists study the chemistry of old buried channels by sampling the water that drains from them. They find traces of the ancient landscape mixed with the marks of modern life. The two layers sit together, century upon century, flowing through the same low ground. The cycles run on longer scales too. Cities themselves rise and fall. Some old cities that once buried their rivers have begun to uncover them again. Workers peel back the concrete, take down the walls, and let the river see the sky for the first time in 100 years. In Seoul, a stream called the Cheonggyecheon was freed from beneath a highway and now flows through the heart of the city. The pulse of the water, once hidden, came back into daylight. How many other buried streams could be opened in the same way is an open question, and every city answers it differently. The deepest mystery may be the oldest one. Before any city stood, these little streams had their own histories, reaching back thousands of years. They cut their valleys into soft soil. They fed marshes where birds rested on long migrations. They drew the first people to settle nearby, because fresh water is always the first reason to stay. The shape of many great cities was set, long ago, by the bends of streams that no living person has ever seen. The cycles of those vanished waters still hum, faintly, under the streets. So when you walk through an old city, you may be walking above a quiet pulse. A small river, still doing what rivers do, rising a little in spring, falling a little in autumn, carrying its grains of sand toward the sea. Most of these ghost streams are not fully mapped. Most of their rhythms are not fully measured. They flow on, patient and unseen, and the full story of what they still shape above them remains. For now, an open question worth wondering about as you rest. In dry valleys across Africa, the Middle East, and Central Asia, people sometimes stoop and pick up small-shaped stones. The stones are old. Some are hand axes. Some are scrapers or sharp flakes meant for cutting hide and meat. They rest now in sand or dust, far from any flowing water. But the people who made them long ago lived beside rivers. The water is gone. The tools remain. This is one of the quietest puzzles in the study of our early ancestors. Stone tools and old riverbeds keep turning up together. In places where the land is now bone dry, archaeologists find clusters of worked stone scattered along the curves of channels that have not held water for tens of thousands of years. The channels show up as faint ribbons in satellite images or as paler bands in the soil. Walk those bands, and the ground gives up its old gifts. In the eastern Sahara, surveys have mapped long lines of stone tools that trace what once were streams and shallow lakes. In Arabia, in places now covered by dunes, similar finds appear along the ghost paths of vanished rivers. The pattern is not random. Early humans and the species that came before us seem to have followed water across landscapes that look, today, almost lifeless. The mystery is how wide that green network really was, and how often it opened and closed. The leading idea is that the climate shifted in long, slow rhythms. During wetter periods, monsoon rains pushed farther north than they do now. Rivers ran where deserts now lie. Lakes filled the low places. Grass and trees spread, and animals followed, and people followed the animals. Then the rains pulled back. The rivers thinned. The lakes shrank into salt pans. The people moved on, or stayed and adapted, or vanished from that place entirely, leaving only the stones behind. Some researchers picture these wet phases as broad green corridors, allowing whole populations to walk from one continent to another along chains of rivers and lakes. Others wonder if the green was patchier than that, more like scattered oases linked by thin threads of water that came and went with the seasons. The difference matters. A wide corridor would have let many groups move freely. A patchwork would have funneled them through narrow passes, shaping which paths survived and which were lost. The stone tools themselves are quiet witnesses. A hand axe shaped 500,000 years ago does not say who made it or where they were going. It only says that someone sat by water, struck flake after flake from a stone core, and left the result on the bank. The river kept flowing for a while, then it slowed, then it stopped. The bank became a slope of dry gravel. The tool waited. There are other neighbors to consider. Bones of ancient elephants, hippos, and giant cattle have been found in some of these dry valleys, locked into old mud layers. Their presence confirms that the water was once deep enough and steady enough to support large animals. Fish bones turn up too, and freshwater shells, and the shells of snails that only live in slow, weedy streams. Each fragment adds a little more to the picture of a vanished ecosystem that early humans walked through and used. What remains unknown is the timing of it all. Dating a dry riverbed is hard. Dating a stone tool lying on the surface is harder. Researchers use the layers around the fines and the chemistry of the sediments and sometimes tiny grains that record when they last saw sunlight. The dates cluster into wet windows and dry windows, but the edges of those windows are blurry. Whether a particular tool was dropped during one green phase or another is often a matter of careful guesswork. There is also the question of how the rivers themselves remembered their old paths. Some seem to have returned to nearly the same channels each time the rains came back. Others wandered, cutting fresh roots through soft ground. The reasons are not fully understood. Bedrock shape, slope, and old sediment all play a part. So perhaps did the slow rise and fall of the land itself. For tonight, picture the scene. A shallow river runs through low grass under a warm sky. A small group rests on the bank. Someone is working a piece of flint, slowly, patiently, the chips falling into the dust. The water moves past, carrying leaves. Thousands of years from now, the water will be gone. The dust will still be there. So will the chips. So will the quiet question of who they were and where they were going next. Tonight, let us drift far back in time, to an Amazon that almost no one ever pictures. The river we know today flows east. It begins high in the Andes Mountains of South America, and it pours its brown water across an entire continent into the Atlantic Ocean. It is the largest river on Earth by volume. No other river even comes close. Roughly 1/5 of all the fresh water flowing from land into the sea moves through this one channel. But the Amazon has not always done this. The river is much older than the mountains that now feed it, and in its earliest life, it may have flowed in the opposite direction. Picture South America before the Andes existed. The western edge of the continent was low and quiet. No tall peaks, no high snow, no glaciers feeding rivers down icy slopes. To the east stood a different range, much older and now mostly worn away. These were the highlands of what we now call the Guiana Shield and the Brazilian Shield. Some of the oldest exposed rock on Earth sits there, more than 2 billion years in age. The land tilted gently from east to west, and rainwater followed that slope. So one theory, supported by sediment studies and tiny mineral grains called zircons, suggests that the early Amazon flowed westward. It collected rain from those ancient eastern highlands and carried it across the continent toward the Pacific. There may have been a long, shallow seaway on the western side, or a vast inland basin of lakes and wetlands. The river emptied into that low country and went no further. Then, slowly, the Andes began to rise. The South American plate pushed against the Pacific seafloor, and that seafloor slid down beneath it. Rock crumpled upward. Over tens of millions of years, a wall of mountains lifted along the western coast. The old westward drainage hit a rising barrier. Water pooled behind it. Some researchers think a huge inland wetland formed, a slow, soupy world of shallow lakes called the Pebas system. Fossils from this period show strange crocodiles, freshwater stingrays, and giant turtles living together in warm, murky water. The question of what happened next is still being studied. At some point, perhaps around 10 million years ago, perhaps a bit later, the river changed its mind. It found a new path eastward, cutting through the older shields and pouring into the Atlantic. The Amazon became the river we know now, running from young mountains in the west to an ancient ocean in the east. But the exact timing remains unsettled. Different sediment cores give different ages. Different scientists read the clues differently. One group argues the modern eastward Amazon is quite young, only a few million years old in its present form. Another group sees evidence for a much earlier turning. The debate is quiet but ongoing. The extremes of this river are difficult to hold in the mind. At its mouth, the Amazon is so wide that you cannot see across it. The main channel stretches more than 200 miles from bank to bank where it meets the sea, though much of that width is broken by islands. One of those islands, Marajo, is roughly the size of Switzerland. The river carries so much fresh water into the Atlantic that the ocean tastes less salty for over 100 miles offshore. Sailors centuries ago noticed this and dipped buckets over the side to drink, long before any land came into view. Beneath the visible river, researchers have proposed something even stranger. Studies of deep groundwater suggest a slow, broad flow of water moving through porous rock far below the surface, sometimes called the Hamza. Whether this counts as a true river is debated. Most geologists describe it instead as a wide zone of seeping groundwater, not a flowing channel in any familiar sense. The mystery of what truly moves beneath the Amazon is still open. And so the river we picture today, brown and warm and slow, is only the most recent version of itself. Before the Andes, it may have run the other way. Before the eastern shields wore down, it may have carried very different sediment, very different fish, very different life along its banks. The water in its present channel is fresh and young, only weeks old since the last rainfall. But the path it follows is a palimpsest, written and rewritten across geological time. How many times has this river reversed itself in deep history? We do not fully know. The clues lie in mineral grains and ancient muds, in patterns scientists are still learning to read. For tonight, it is enough to imagine a quiet continent slowly tilting and a river slowly changing its mind. For as long as people have lived beside rivers, they have whispered to them. Long before the first written prayer, before the first carved stone, humans seemed to sense that moving water held something quiet and important. We find traces of this everywhere. Small offerings tucked into the mud of riverbanks, bronze pins, polished stones, tiny figures of clay. Why people did this in so many places across so many ages is a question we still cannot fully answer. In the rivers of northern Europe, archaeologists have pulled up swords bent in half. Some were folded back on themselves before being dropped into the water. The blades were valuable, often new, sometimes barely used. One idea is that the bending was a kind of farewell, a way of saying the object now belonged to the river and to no one else. Another theory is that the folded metal marked the end of a person's life, and the river served as a quiet keeper of memory. The truth may sit somewhere between these gentle guesses. The River Thames in England has given up thousands of such gifts, shields, helmets. Smooth blades wrapped in green river patina. The mud holds them softly, sealing out the air, slowing the slow work of rust. When divers find these objects, they often lie close to old fords and bends, places where people would have crossed or paused. Some researchers wonder if these spots were considered thresholds, where one world touched another. Others think the offerings simply marked safe places, where the water was kind enough to let a traveler through. Far to the south, in the warm rivers of India, the practice of honoring water has never stopped. The Ganges has carried prayers for thousands of years. Small lamps float on its surface at dusk, flickering points of light drifting downstream. The river is treated as a living presence, with moods and memory. Scientists studying its waters have found unusual properties, high levels of dissolved oxygen, certain microbes that seem to slow the growth of others. Whether these qualities helped shape the old beliefs, or whether the old beliefs simply noticed something real, remains an open and quiet puzzle. In the highlands of the Andes, springs that feed great rivers were once marked with carved stones. Some of these stones are small, no larger than a hand, polished smooth by centuries of touch. Others are great slabs set into the earth where water rises up from below. The people who placed them are gone, but the stones remain. Researchers find them tucked into mossy hollows, half buried in soft turf. Why these specific springs were chosen, and not the thousands of others nearby, is something we may never learn. Across the rivers of West Africa, certain stretches of water were once considered the home of ancestors. Fishermen would speak softly when passing these places. Nets were sometimes lifted and lowered in particular patterns, in a kind of greeting. Anthropologists who have recorded these traditions find that the same bends and pools, the same quiet eddies, often appear in stories told hundreds of miles apart. Whether this points to a shared older belief or to something each community arrived at on its own is still being studied. In Japan, small wooden shrines stand beside countless mountain streams. Some are only a few inches tall, half hidden in ferns. Travelers leave a coin, a flower, a folded paper. The streams themselves are often named, each one given a personality of its own. A scientist might call them tributaries. The old language calls them visitors, guests, slow walkers down from the high places. What draws the human mind to moving water in this way is something even psychologists wonder about. There is a soft hush in the sound of a river, a low frequency that seems to settle the breath. The slow shimmer of light on its surface holds the eye without tiring it. The way the water is always the same shape, but never the same water present, yet always passing, touches something in us that words struggle to name. Some researchers believe this response is very old, woven into us by long ages of living beside such places. Others think it is something we learn fresh each time, in childhood, the first time we sit by a stream. Whatever the cause, the rivers have been listening to us for a very long time. They have taken our offerings, our prayers, our quiet thoughts at evening, and carried them on without complaint. The bronze pins still rest in the mud, the carved stones still sit beside the springs, and the water still moves, soft and steady, the way it has always moved, holding our small wonderings inside its long and patient flow. Rivers almost never run in straight lines. Given enough time and soft ground, they curl, they loop, they bend back on themselves in long, lazy arcs that swing across the land like slow handwriting. These bends are called meanders, and for a long time, no one quite understood why they form. The word itself comes from an old river in what is now western Turkey. The Greeks called it the Meandros, and they watched it wander through a flat valley in long, looping curves. Travelers in the ancient world remarked on its strange, restless path. By the time of the Roman writers, the river's name had already become a verb. To meander was to wind, to drift, to take the slow way. For centuries, people simply accepted that rivers curved. The bends seemed natural. The way trees grew branches or clouds took shapes. The deeper question, why a river that could flow straight would choose to wander, waited a long time for anyone to ask it carefully. The first hints came from surveyors and mapmakers in the 17th and 18th centuries. As empires drew careful charts of their rivers for trade and taxation, the curves began to look less random. Mapmakers noticed that bends often came in matched pairs, where one bank curved outward, the other curved inward, like two slow dancers leaning toward and away from each other. The wavelength of the bends seemed to scale with the size of the river. Big rivers made big loops. Small streams made small ones. In the 19th century, a new generation of scientists began studying rivers as physical systems. They watched how water moved through bends. They saw that on the outside of a curve, the water ran a little faster and dug into the bank, carrying soil away. On the inside, the water slowed and dropped its load of sand, building up a low, curving beach. Over decades, this quiet trade of erosion and deposit pushed the bend wider and wider. The river was not just curving. It was eating its way sideways across the valley. One of the great early observers was a thoughtful American named Albert Einstein's father-in-law's contemporaries. But more importantly, the puzzle eventually drew the attention of Albert Einstein himself. In a short paper, he suggested that the curving flow of water inside a bend behaved a little like the swirl of tea leaves in a stirred cup. The water at the surface spiraled outward, while the water near the bottom spiraled inward, carrying sediment along the floor of the channel. It was an elegant idea. It explained some of what was seen, but it did not fully explain why bends began in the first place, or why they kept their orderly shape. Other researchers studied rivers in glass-sided tanks and outdoor flumes, long troughs filled with sand and water. They tilted the troughs, let the water run, and watched the channels carve themselves. Almost always, the channels began to bend. Even with no obstacles, no boulders, no soft patches in the soil, the water would not stay straight. Some small wobble would amplify. The bend would grow. The pattern would repeat. This suggested that meanders were not caused by something in the way of the river. They were caused by something inside the river itself. A flowing liquid, given the freedom to choose its path through loose ground, seemed to prefer curving. Why exactly remains a question scientists still discuss. Some point to the way energy moves through the flow. Some point to the spiral currents Einstein described. Some look to the way sediment builds and collapses along the banks. The full answer may involve all of these working together. There is also the strange behavior of meanders over long time. A bend will swing outward until it nearly meets itself. Then, in a single flood, the river may cut across the narrow neck and abandon the old loop. The abandoned curve becomes a still, crescent lake, an oxbow, slowly filling with reeds and silt. The river has straightened, only to begin curving again somewhere else. From the air, an old river plain looks like a notebook scribbled with ghosts of its former selves. Each faint curve in the soil marks a path the water once took. Some of these ghost bends are thousands of years old. Some are older still, pressed into rock from rivers that no longer exist. The riddle of why rivers bend the way they do is partly solved and partly not. We know much more than the ancient Greeks did. We can model the flow with equations and computers. The deeper question of what truly decides the shape of a curve on a particular river in a particular year still drifts quietly downstream. Almost every old culture remembers a great flood. The stories come from places that never met, from people who could not have shared a single tongue. The rivers of Mesopotamia hold tales of a deluge that swallowed the world. The valleys of China remember waters that rose without warning, swallowing fields and villages whole. The hills of South America keep stories of rivers that turned on their people. The forests of northern Europe whisper of seas that climbed the land. So many stories in so many places, all carrying the same quiet shape. For a long time, scholars treated these flood tales as pure invention. They seemed too dramatic, too universal, too convenient. But over the last century, geologists have begun to wonder if some of them might be old memories, passed down so many times that the names changed but the shock remained. The question is open, and it is a strange one. Can a river flood survive in human memory for thousands of years? One famous case sits at the bottom of the Black Sea. Some researchers have proposed that around 7,000 years ago, the Mediterranean broke through a narrow ridge of land and poured into a smaller freshwater lake beyond. If this happened the way they describe, the water would have risen quickly, drowning shorelines where people lived and farmed. The villages along those shores would have vanished beneath a new salty sea. Other scientists disagree about the speed and scale of the event. Some think the rise was gentle and slow, not the violent surge the first theory described. The sediments tell parts of the story, but not the whole of it. The debate continues in quiet, careful papers. In central China, geologists found evidence of an enormous landslide along the Yellow River, somewhere around 4,000 years ago. The landslide blocked the river, formed a vast lake behind it, and then broke. When it broke, the water rushed downstream in a wall, scouring villages and reshaping the valley floor. Old Chinese legends speak of a great hero who tamed a terrible flood by digging channels to let the water out. Some researchers wonder if the legend remembers the real disaster, dressed in the clothing of myth. Others are not convinced. The dates line up in interesting ways, but the link between stone and story is hard to prove. The question stays open. Then there are the floods left by the melting of the last ice age. As the great ice sheets retreated, they left enormous lakes held in by walls of ice and rubble. When those walls broke, the water released was almost beyond imagining. In what is now the northwestern United States, a single ice dam failure sent a wall of water racing across the land, carving deep channels into the bedrock and leaving ripple marks the size of hills. These floods happened over and over, perhaps dozens of times. No people lived there at the moment of the very first surge. But humans were on the continent by the end, and they may have watched some of the last ones happen. Across the planet, similar ice dam floods scoured Siberia, reshaped parts of Europe, and carved long valleys in Central Asia. The scale of these events is hard to picture. A single flood could move more water in a few days than all the rivers of the world carry in a year. Where this water went, the land changed forever. Cliffs were stripped bare. Boulders the size of houses were carried for miles. Old soils were swept away, leaving fresh rock open to the sky. It is strange to think that some of the deepest river valleys we see today were not carved slowly by gentle currents, but cut in a few violent days by water no one alive ever witnessed. The rivers that flow through these valleys now are quiet ghosts of those great surges. They wind through landscapes shaped by an older, wilder version of themselves. Whether the flood myths of human cultures actually remember any of this is something we may never settle. Memory is a fragile thing. A story told around a fire can survive for a long time, but it changes with each telling. By the time it reaches us, the river in the story has often become a god, and the flood has become a punishment, and the land has become a place no map can find. The geology and the legend may be talking about the same event, or they may be reaching toward different truths from opposite directions. The river itself, flowing past as we wonder, gives no answer. It only keeps moving, carrying what it carries, washing the question gently downstream toward some other listener on some other quiet night. Beneath our feet in the darkness we rarely think about, rivers are flowing. They move through caves and cracks, through layers of limestone and chalk, through gravel beds buried far below the surface. These underground rivers connect to the ones we know, the ones we can see. They feed them, drain them, and sometimes vanish from them entirely, only to reappear miles away in some quiet spring. The whole system breathes together, above and below, in ways we are still learning to map. Limestone is the great storyteller here. Soft rain, made slightly acidic by carbon dioxide in the air, falls onto the land and seeps down through cracks in the stone. Over thousands of years, that gentle water dissolves the limestone from within. It carves rooms. It carves halls. It carves long, winding passages that hold rivers of their own. Some of these hidden rivers are small, no wider than a hallway. Others are wide enough to float a boat through, deep in the cool dark, with ceilings of pale stone curving overhead. The mystery is how all of these waters speak to one another. A river on the surface may sink into the ground in one place, travel for miles through stone, and rise again in another valley entirely. Sometimes the path is known, often it is only guessed at. Researchers have poured harmless dyes into sinking streams and waited, sometimes for weeks, to see where the color reappears. The answers can be surprising. A stream that disappears on one mountainside may emerge on the far side of a ridge, having traveled through a network no human has ever walked. These hidden flows connect the land to the sea in quiet ways. Rain that fell on a meadow last spring may be moving, right now, through a buried channel toward the coast. When it finally reaches the ocean, it may seep out from springs along the seafloor, places where fresh water mixes with salt in slow underwater clouds. Fishermen in some parts of the world have known about these springs for centuries. They sail to them, lower buckets, and bring up drinking water from the middle of the sea. How much fresh water leaves the continents this way, through underground rivers that never show themselves above ground, is still an open question. The numbers we have are estimates, and the estimates keep changing. The connection runs the other direction too. The sun warms the ocean. The ocean lifts water into the sky. The sky carries clouds inland, drops them as rain, and the rain begins the long descent again, first into surface streams, then into the cracks below, then through the dark passages of stone, then back to the sea. Underground rivers are one quiet part of this larger turning. They are slow. A drop of water entering a deep aquifer may not see daylight again for 1,000 years. Some of the water flowing through the world's hidden channels fell as rain when the Great Pyramids were still new. Caves carved by these rivers hold their own ancient archives. The slow drip of mineral-rich water builds stalactites from the ceiling and stalagmites from the floor. Each layer records something about the climate above, how wet the year was, how warm, how the forests were breathing. By reading these stone rings, the way one might read tree rings, researchers can study whether that happened long before any human wrote it down. The underground rivers, in a sense, keep notes for the surface world. They remember droughts and monsoons that nobody else recorded. There is a deeper puzzle, too. Some underground rivers seem to be cut off from the surface entirely. They flow through chambers so old and so isolated that the creatures living in them, pale, eyeless fish, ghostly shrimp, translucent salamanders, have evolved in darkness for millions of years. How these waters connect to the broader cycle, if they connect at all, is not fully understood. A few of these hidden ecosystems may be nearly closed systems, recycling the same water in their own slow loop. The boundary between an underground river and an underground sea grows blurry the deeper one looks. What the surface world calls a river, then, is only the visible part of something much larger. Below every flowing stream there is usually another stream, slower and quieter, moving through the rock. Below that, sometimes, there is another. They braid together in ways we are still tracing. The full map of Earth's water, surface, soil, stone, sea, sky has not been drawn. We have sketches. We have hints. We have dyes that vanish into one cave and rise from another. The rest is still being learned slowly in the dark. The Mississippi River, that long brown ribbon winding down the heart of North America, has never stayed in one place. It looks settled on a map. It looks like a fixed line, drawn once and held forever. But the truth is gentler and stranger than that. The Mississippi is a river that wanders. Across the slow span of thousands of years, it has swung back and forth across its wide floodplain like a rope laid loose on a table, slipping into one shape and then another. Geologists who study the lower river have traced these old paths in the soil. They find buried channels, curved ridges, and crescent lakes where the water once flowed and then moved on. Each of these scars marks a former life of the river. One ancient course ran far to the west of where the river runs today. Another swept east toward what is now Mobile Bay. The river we see now is only the most recent draft. The earlier drafts lie underfoot, soft and quiet, hidden beneath fields and forests. Why does a river wander like this? The simple answer is that flat land gives a river room to roam. When the Mississippi reaches its lower plane, the slope becomes very gentle. Water moving slowly carries soft mud and sand. It piles that sediment up along its banks, building natural walls a little higher than the land beyond. Over centuries, the river floor itself rises. Eventually, the river sits perched above the country around it. Then, during some great flood, the water breaks through a weak spot and chooses a lower, easier path. The old channel is left behind. A new one begins. This kind of slow leap has a name. Scientists call it an avulsion, which simply means a sudden shift of the channel into a new course. The lower Mississippi has done this many times. Some researchers count 7 major shifts over the last 7,000 years. Others count more or fewer, depending on how they read the layers in the mud. The exact history is still being argued. What everyone agrees on is that the river is restless. It has no loyalty to any one path. Right now, quietly, the Mississippi is trying to do it again. Not far above the city of Baton Rouge, a smaller river called the Atchafalaya offers a shorter, steeper route to the sea. Water naturally wants to take that shorter path. Without human help, the Mississippi would likely have already jumped. Engineers built a great structure of concrete and steel decades ago to hold the river in its current course. The structure works for now, but the river still pulls. It still pushes against the gates. The question of how long the current channel can be held is an open one. Some say many decades, some say less. The river keeps its own counsel. These shifts matter because cities now sit along the banks. Ports, farms, and towns were built on the assumption that the river would stay. The river does not know about that assumption. It remembers older paths. It remembers a time before levees, before maps, before any human eye watched it from a bridge. The land between the old channels is, in a way, a kind of memory written in soil. Walk across the Louisiana lowlands, and you are walking across the river's earlier lives. Looking further back, before the last ice age ended, the Mississippi carried meltwater from glaciers far to the north. The river was wider then, and rougher, and full of stones and gravel that no modern visitor would recognize as Mississippi mud. As the ice retreated, the load it carried changed. The river slowed, softened, and began to braid itself into the looping shape we see today. Even the color of the water, that famous heavy brown, is a recent thing in geological terms. Looking forward is harder. Researchers studying the river's behavior wonder how rising seas, sinking deltas, and stronger storms might change the next chapter. Some think the river may break free in a sudden flood season. Others believe it can be held with enough care for a very long time. No one knows which view is right. The river is too slow for any single human lifetime to settle the question. So the Mississippi keeps doing what it has always done. It carries mud south. It pushes against its walls. It dreams in its own slow way of the shorter path. And the old channels lie quiet beneath the fields, waiting, perhaps, to feel water move through them again one day. How and when that might happen, no one can yet say. The river will decide in its own time, on a scale far longer than ours. Where a river finally meets the sea, the water slows, spreads, and lets go of all the small pieces of stone it has been carrying. These pieces settle in soft fans of sand and silt, building outward in long, low arms that reach into the ocean. We call these places deltas. From above, they look like open hands, or like the veins of a giant leaf pressed flat against the coast. And when sunlight falls on them, they shine in colors no other place on Earth can quite match. At sunrise, a delta glows in soft gold and copper. The shallow water reflects the sky in 1,000 small mirrors, broken by reeds and low islands. Pale sandbars rise just above the surface, still wet from the night tide, gleaming like polished bone. Birds drift across in long lines, their shadows skimming the bright water. By midday, the colors shift to softer greens and milky browns, the silt in the water catching every ray of sun and scattering it back in a gentle haze. Each grain of that silt has its own long story. Some of it began in mountains 1,000 miles inland, broken from cliffs by frost and rain. Some came from old volcanoes worn down over millions of years. Some came from even older rocks that were themselves once river mud in some forgotten age. When you look at a shining delta, you are looking at deep time laid out in soft layers, lit by the sun. The light tells the story if you know how to read it. Pale yellow sands often come from quartz, one of the toughest minerals, able to survive long journeys downriver. Dark gray muds often hold tiny flakes of mica, which catch the light in small silver glints. Reddish bands hint at iron, slowly rusting through the centuries. A delta in full sun is a quiet museum of color, and every color points back to a different source somewhere upstream and somewhere long ago. Yet for all that we can see on the surface, much of a delta lies hidden below. Beneath the bright shallows, layers of older sediment stretch down for hundreds of meters, sometimes more. Each layer is a chapter from a different climate, a different river mood, a different slice of the past. And here the mysteries begin. We do not always know which ancient river built which deep layer. Rivers wander over the ages. They shift their mouths from one part of the coast to another. The delta we see today may sit on top of mud, delivered by a river that no longer exists in the same form. One idea is that the great deltas grew steadily, layer by layer, in long, quiet pulses. Another idea is that they grew in bursts, during wetter periods when storms washed huge amounts of sediment downstream in short, dramatic seasons. The truth is probably some mix of both. But the exact rhythm, the exact pattern of fast and slow, remains an open question for many of the world's largest deltas. Light helps researchers test these ideas in surprising ways. Tiny grains of certain minerals, once buried, hold a faint memory of the last time they saw sunlight. Scientists can measure this trapped signal in a darkened lab and estimate how long ago each grain was covered over. In this way, a delta becomes a slow clock, ticking in light that was hidden away thousands or millions of years ago. Still, the readings are never complete. Layers get mixed by burrowing animals. Storms scramble the order. Some questions stay just out of reach. At dusk, a delta glows again, this time in pinks and lavenders. The shallow channels catch the low sun and turn into ribbons of soft fire. Long shadows stretch across the mudflats. Egrets fold themselves into the reeds. The river, after its long inland passage, breathes out into the calm sea, and the colors slowly cool toward blue. Some researchers wonder how much longer certain great deltas will keep their shape. Rivers carry less sediment when dams hold the water back upstream. Seas rise gently as the climate shifts. A delta is a balance, built grain by grain over deep time, and balances can tilt. Whether today's deltas will keep growing or slowly sink back beneath the waves is another open question the next centuries will answer. For tonight, picture the soft glow at the edge of a sleeping coast. Picture the silver glints of mica, the gold of quartz, the dark bands of old iron, all settled in quiet layers under the shallow water. Light falls on the surface, and beneath it, deep time is gently folded, layer upon patient layer, waiting in the warm dark. Beneath the great ice sheets of our world, water still moves. It carves channels along the dark stone floor, far below thousands of feet of frozen weight. These are rivers buried by ice, and we are only beginning to listen to them. For most of human history, no one knew they existed. The ice seemed solid, silent, dead, but it is not. When scientists first lowered sensitive microphones into boreholes drilled deep into the ice in Antarctica and Greenland, they heard something they did not expect. They heard the soft hiss of water flowing in the dark. They heard low groans as the ice shifted on its hidden bed. They heard sudden cracks like distant thunder when pressure built up and gave way. The ice was not quiet at all. It was singing a slow, strange song made of meltwater and stone. These buried rivers form in a curious way. The ice above them is so heavy that it presses down with enormous force. That pressure, along with a slow trickle of heat rising from the rock below, melts the bottom layer of ice into water. The water gathers in thin films, then in trickles, then in streams. It flows along the contours of the bedrock, just as a normal river flows along a valley floor. The only difference is the ceiling. Above these rivers there is no sky, no air, no sound from the world we know. Only ice pressing down, holding the dark. Some of these rivers are large enough to fill whole lakes beneath the ice. In Antarctica, researchers have found hundreds of such hidden lakes connected by hidden channels. The largest, called Lake Vostok, sits buried under more than 2 miles of ice. It has been sealed off from sunlight for millions of years. One theory is that strange microbes still live in its black, cold water, surviving without sun, without seasons, without any contact with the surface world. Another view is that the conditions are simply too harsh, and the water is mostly empty of life. The samples taken so far have been tantalizing but inconclusive. The question remains open. The sounds these buried rivers make are not random. They carry information. When ice shifts above a flowing channel, the vibrations travel for miles through the frozen sheet. Scientists place sensors on the surface and listen patiently, like doctors with stethoscopes pressed against a sleeping giant. Sometimes they hear a slow rumble that lasts for hours. Sometimes a sharp pop, then silence. Sometimes a long, low tone, almost like a sigh. Each sound is a clue, but the meaning is not always clear. One of the more puzzling sounds is a deep, repeating pulse that has been picked up near certain ice streams. Some researchers wonder if it comes from water surging through a narrow passage, like wind whistling through a doorway. Others think it might be the ice itself, flexing and releasing in steady rhythm as the river below swells and shrinks. No one is sure. The ice keeps its secrets well. These buried rivers are not just curiosities, they shape the world above them. When a hidden river grows full and pushes its way out toward the sea, the ice above can slide faster, sometimes much faster, toward the coast. A glacier that once crept along at a slow walking pace can suddenly speed up, sending great slabs of ice toward the ocean. The water below acts like grease on the floor of the world. How often this happens and what triggers it is still being studied. There are older buried rivers too, ancient ones, frozen into the record of the ice itself. When scientists drill deep cores from Greenland and Antarctica, they sometimes find layers that suggest meltwater once flowed in places that are now deeply frozen. Some of these channels date back tens of thousands of years, maybe more. They are echoes of warmer times, preserved in the cold. What they sounded like when they ran free, we can only imagine. There is something quieting about the thought of these hidden waters. Far beneath the wind and the snow, beneath the bright cold surface of the polar world, soft rivers are still moving. They flow without witnesses, without light, without any urgency at all. They have been flowing this way for ages. They will keep flowing for ages more. What lives in them, where exactly they go, how they shape the ice above, and what their slow songs are truly telling us. These questions are still being gathered, piece by piece, recording by recording. For now, the listening continues, and somewhere under the ice, in the long, patient dark, a buried river slips quietly along its ancient bed, singing its small song to no one in particular. Walk along almost any coastline in the world, and you may be standing at the mouth of a river that is much longer than it looks. The water you see flowing into the sea is only the upper portion. The rest of the river, the older portion, lies underwater. It was carved long ago, when the oceans were lower and the land stretched farther out. These hidden channels are called drowned valleys, and they are some of the most quietly beautiful shapes in all of geology. The numbers behind them are simple, almost gentle. During the last ice age, so much water was locked up in great sheets of ice that sea level sat about 120 meters lower than it does today. That single number changes everything. 120 meters down, vast areas of the modern seafloor were dry land. Rivers crossed those plains. They cut valleys into them. They carried sand and gravel toward shorelines that no longer exist. Then the ice began to melt. Sea level rose, slowly at first, then in long surges. The ocean crept inland, climbing the old river valleys from below. Water filled the channels, salt mixed with fresh. The lower portions of the rivers vanished beneath the waves. What remained on land was only the top of a much older system. You can see the math of this written into the shape of certain coasts. A drowned valley, seen from above, looks like a long finger of sea reaching deep into the land. The sides are steep. The bottom is flat and quiet. Smaller side valleys join the main one at gentle angles, just as tributaries join a river on dry ground. These shapes are called rias, and they trace the exact path the river once took, only now they are full of seawater instead of fresh. The ratios involved are surprisingly tidy. Rivers tend to carve valleys whose width grows in proportion to the volume of water they carry. When the sea rises and floods the valley, that ratio is preserved. You can stand on a clifftop above a drowned coast and read, in the width of the inlet, a rough memory of how big the ancient river once was. The math survives the flooding. It simply waits underwater. Some drowned valleys are enormous. Off the eastern coast of North America, beneath the shallow waters of the continental shelf, geologists have mapped the old channel of the Hudson River. It runs out past the modern coastline for many tens of kilometers, then plunges into a deep canyon that drops thousands of meters toward the abyss. The numbers there are harder to picture, but they are still elegant. A river that today seems modest once carved a trench longer than many mountain ranges. The Hudson is not alone. Off the coast of England, beneath the cold gray waters of the North Sea, lies a sunken plain that researchers call Doggerland. Rivers crossed it, hills rose from it, people lived on it. As the ice melted, the sea swallowed the whole region, leaving only the river valleys etched into the seafloor as faint lines. The mathematics of melting ice and rising water turned an entire country into a memory. What remains uncertain is how quickly all of this happened. The general numbers are well understood. The fine details are not. Some evidence suggests sea level rose in sudden pulses, with meters of rise in only a few generations. Other evidence suggests a slower, steadier climb. The truth probably involves both, but the exact rhythm is still debated. One theory holds that great freshwater lakes, dammed by ice, broke loose and added sharp surges to the rise. Another suggests the ice itself collapsed in stages. The math of the past is clean. The timing remains open. There is something soothing in the geometry of a drowned valley. The river once obeyed simple rules. Water flows downhill. It cuts where it is fastest. It deposits where it slows. The sea, in turn, obeys its own simple rule. It fills whatever shape it finds. When the two rules meet, they produce these long, calm inlets, mirror-smooth on still mornings, lined with forests or low hills that lean toward the water as if listening. The universe in this small corner of it runs on a few quiet equations: ice mass, sea level, channel width, erosion rate. The numbers do not shout. They simply add up century after century, until the shape of a coast becomes a record of how much water the world chose to hold in solid form and how much it chose to release. Somewhere beneath your nearest sea, an old river is still there, drawn in the dark, waiting to be read. Rivers do more than carry water, they carry time. In the slow brown mud at the bottom of a river, the bones of long-vanished creatures sometimes come to rest. A leg bone here, a tooth there, a whole skull tumbled smooth by the current. River mud is one of the great keepers of the fossil record, and the conditions that allow this keeping are surprisingly delicate. Think of what has to happen for a fossil to form. An animal dies near the water. The body must sink fast before scavengers tear it apart. Mud must cover it gently, sealing it away from oxygen. The river must keep flowing year after year, century after century, laying down more mud on top. Slowly, minerals seep into the bones. The soft parts vanish. The hard parts turn to stone. Lift one variable out of place, and the whole quiet process fails. The angle of the riverbed matters. If the slope is too steep, the water runs fast and washes the bones away. If the slope is too gentle, the water sits still and the bones rot before they can be buried. Somewhere between these two extremes is a narrow band where preservation works. Rivers find that band by accident. They find it for a few thousand years, then lose it again as the channel shifts. The chemistry of the water matters too. Slightly acidic water dissolves bone. Slightly alkaline water preserves it. The amount of iron in the mud changes the color and the hardness of what survives. The amount of clay decides whether fine details, like the tiny ridges on a tooth, are kept or smoothed away. Each river has its own quiet recipe, written by the rocks upstream. The climate matters as well. A river that freezes solid each winter buries things differently than a river that floods each spring. A river in a dry land may shrink to a trickle and expose its old bed to the sun, cracking the buried bones. A river in a wet forest may grow so full of roots that fossils are pulled apart by living things searching for water. The fossil record we have today is shaped by all of these forces working together, in just the right amounts, in just the right places. Some of the richest fossil beds on Earth are old river deposits. The dinosaur-bearing rocks of the American West were laid down by ancient rivers winding across warm floodplains. The early human fossils of East Africa come from lakeshores and river mouths where rising water sealed bones into layered mud. In China, in Argentina, in Mongolia, the same pattern repeats. Where rivers once ran slow and steady and rich with sediment, the past has been kept. Yet much remains uncertain. Researchers still debate how much of the fossil record is biased by these conditions. Are we seeing the true variety of ancient life, or only the creatures that happen to die near the right kind of river? One idea is that whole groups of animals, especially those that lived in dry uplands far from any water, may be almost entirely missing from the record. Another view holds that the gaps are smaller than they look because rivers, over enough time, sample most environments at least a little. The question stays open. Each new dig sharpens it without settling it. The fragile balance of all this is easy to overlook. Earth sits at just the right distance from the sun for liquid water to exist on its surface. The atmosphere holds just enough warmth, but not too much. The crust moves slowly enough to build mountains, which feed rivers with sediment, but not so fast that everything is shaken loose. The tilt of the planet brings seasons, which bring floods, which bring new mud. Pull one of these settings even slightly out of place, and rivers as we know them would not exist. Neither would the long memory they hold. When you walk beside a slow river and watch the muddy water curl past a sandbar, you are looking at a process that has been running, in some form, for billions of years. Bones are settling somewhere in that mud right now. Most will be lost. A few, in places where the slope and chemistry and climate align, will become the fossils of a distant future. Whether anyone will ever find them is another open question. Whether the conditions that allow this slow keeping will hold steady through the coming ages is yet another. The river does not know. The mud does not know. It only knows how to settle, layer by layer, in the quiet dark beneath the moving water, holding what it happens to hold and forgetting the rest. Rivers do more than carry water, they carry people. And where people gather, language grows. For as long as humans have lived along riverbanks, words have traveled with the current, passing from village to village, mouth to mouth, generation to generation. Some researchers believe the great river valleys of the world may have been the birthplaces of entire language families. But how exactly that happened, and which rivers shaped which tongues, remains one of the quieter mysteries in the study of our past. Think for a moment of the long brown ribbon of the Indus, winding through dry plains under a hot sun. Along its banks, thousands of years ago, a civilization built cities of mud brick and bathed in carefully planned pools. They left behind small clay tablets covered in tiny symbols. We can see the marks. We can trace them with a fingertip, but no one alive today can read them. The Indus script remains undeciphered. Whether it recorded a full spoken language or only names and counts of goods is still debated by scholars who have spent their whole careers staring at those quiet little signs. The river itself may hold a clue. Some linguists wonder if the language of the Indus people survived in fragments, blending into the tongues that came later. Others think it vanished almost completely, washed away as new peoples moved into the valley. The water kept flowing, the words did not. Far to the west, the Tigris and Euphrates tell a similar story with a different ending. Along those twin rivers, the people of ancient Sumer carved wedge-shaped marks into wet clay. That writing we can read. It gives us hymns, laws, love poems, and shopping lists from 4,000 years ago. Yet Sumerian itself is what scholars call a language isolate. It has no known relatives. No mother tongue we can point to, no living daughter languages on the modern map. It simply appears in the river valley, fully formed, and then slowly fades. Where it came from before the clay tablets is a question no one has answered. Rivers seem to do two things to language at once. They gather and they scatter. A wide valley brings people together, mixing their words into something new. A long river also lets travelers carry those words far downstream, seeding new dialects in new villages. Over centuries, the same river can both unite a language and split it into many. The Amazon basin shows this in a way that still puzzles researchers. The forests along its countless tributaries hold one of the densest collections of language families on Earth. Small groups, sometimes only a few hundred people, speak tongues unrelated to their nearest neighbors. How so many distinct languages came to share one river system is not fully understood. One idea is that the rivers acted as highways, letting different peoples settle the basin in many separate waves. Another is that the dense forest itself isolated communities, allowing their speech to drift apart over long, quiet centuries. Both may be true at once. The Niger River in West Africa carries its own puzzle. Along its broad arc, several major language families meet and overlap. Linguists have spent decades trying to trace which words came first, which spread later, and which arrived only recently with trade. The river has been a thoroughfare for so long that the layers of speech along its banks are tangled like roots in wet soil. Pulling them apart, word by word, is slow and careful work. Even the names of rivers themselves often outlive the languages that gave them. The Danube, the Rhine, the Thames, many great European rivers carry names that come from tongues no longer spoken, languages whose grammar and sound we can only guess at. The name remains. The voice that first spoke it is gone. What we do not know is how much of the world's lost language history is hidden in these river valleys. How many tongues rose along a riverbank, flourished for 1,000 years, and then dissolved without leaving a single written word. How many of the symbols we have found in the Indus, in Old Crete, on small stones in the Balkans, are records of languages still waiting to be understood. The water that carried those voices has long since reached the sea. Some researchers hope that new methods, comparing patterns across thousands of modern languages, might one day let us glimpse the shape of these vanished tongues. Others believe much of that knowledge is simply gone, dissolved like silt into the long current of time. The rivers keep their secrets gently, the way they keep everything, by moving on. And the question of what was first said beside them remains open, quiet, and waiting. Long ago, before the continents wore their present shapes, some rivers ran for distances that are hard to picture now. They crossed whole landmasses. They drained mountains that no longer exist. They carried water and sand and small stones across thousands of miles, depositing them in seas that have since dried up or moved away. When we look at the world today, we see rivers contained within single countries, single basins, single coastlines. But the deep past tells a different story, and the deep future may tell another one still. One of the most striking ideas in geology is the transcontinental river. Long ago, when South America and Africa were joined as part of the supercontinent Gondwana, a great river system may have flowed from what is now Namibia, across the join, and into what we now call Brazil. Sand grains found on one continent seem to match bedrock on the other. The river itself is gone. Its bed has been split in two by an ocean, but its grains remain, scattered across both sides of the Atlantic like the pages of a book torn down the middle. If that river truly crossed a vanished continent, then the future may hold its mirror. The plates are still moving. They drift a few centimeters each year, about the rate at which a fingernail grows. Slow, steady, patient. In 100 million years, the Atlantic may have widened further, or it may have begun to close. Some models suggest that Africa and Europe will press together more tightly, lifting new mountains where the Mediterranean now lies. Other models suggest the Americas will drift west until they meet Asia from the other side. The shape of the next supercontinent is debated, and the river systems that would cross it can only be guessed. Imagine a single river, 1 billion years from now, draining a mountain range that has not yet been born. It might begin in highlands raised by a future collision, then wind across a plain made of soils that were once the floor of a sea. It might pass through forests of plants we cannot picture, watered by rains that fall from a sky slightly different from our own. It might end in a delta along a coast that does not yet exist. None of this is fantasy. It is simply the logical extension of what the rocks already record. Yet much of this future remains an open question. We do not know exactly how the plates will move. Two main ideas compete. One suggests the next supercontinent will form by the closing of the Pacific, drawing the Americas toward Asia. The other suggests it will form by the closing of the Atlantic, bringing the Americas back toward Africa and Europe. Each scenario produces a different map. Each map carves out different river paths. Until we understand the deeper engines beneath the crust, we cannot say which picture is closer to the truth. The sun itself has a future too. In a few 100 million years, it will grow slowly brighter. Some scientists wonder whether this will alter rainfall patterns enough to dry many rivers, or whether new circulation in the atmosphere will keep them flowing in places we do not yet expect. Far further ahead, perhaps 1 billion years from now, the brightening sun may make the oceans evaporate faster than they can return. If that day comes, the rivers will quiet, one by one, and the deltas will harden into stone. But that is a long, long way off, and many turns of the world lie between now and then. In the nearer future, the rivers we know will keep doing what rivers do. The Mississippi may someday cut a new path to the sea, abandoning its present mouth. The Amazon may shift its channels through the soft soils of its basin, as it has done many times before. The Ganges may carry the Himalayas, grain by grain, down to the Bay of Bengal, slowly lowering those great peaks while building new land in the delta. Each of these slow rearrangements is already underway. We will not live to see them complete. The grandchildren of our grandchildren will not either. There is something gentle in this thought. The river you may have crossed today, on a quiet morning, belongs to a long line of rivers reaching backward into deep time and forward into a future no one will witness. It is one stage in a story that began before us and continues after us. The water moves on. The continents move on. The questions of where the next great river will flow, and when and through what kind of world, these remain open, and likely will for a very long time. Step back for a moment and let the river widen in your mind until it touches everything. A river is water in motion, but water itself is older than the planet it flows across. The hydrogen in each drop formed in the first minutes after the universe began, when the cosmos was hot and bright and very young. The oxygen came later, forged inside the hearts of ancient stars that lived and died long before our sun was born. When those stars ended their lives, they scattered their atoms across the dark, and some of those atoms, after billions of years of drifting, gathered together to make the earth. So when a river disappears into the desert sand, or sinks into a buried cave, or dries up beneath a slow-moving glacier, the water itself does not end. It only moves. It rises as vapor into the sky. It freezes into clouds. It falls again as rain on a distant hill. The atoms that once flowed past a Neolithic village may now be falling as snow on a mountain no human has ever named. The river you imagine in your mind tonight is part of a far older river that has been flowing, in one form or another, since before there were continents. Some scientists wonder where all this water first came from. One idea is that it arrived on the backs of comets and icy bodies that crashed into the young Earth. Another is that much of it was already locked inside the rocks that formed the planet, slowly seeping out over millions of years through volcanoes and vents. The truth may be a mixture of both, and the full answer is still not known. Either way, every river is, in a quiet sense, a memory of the early solar system, brought down to the ground and shaped by gravity into long silver threads. The calcium in the bones of the fish that swim in those rivers came from supernovae. The iron that gives river mud its rusty color was forged in the cores of dying stars. The carbon in every leaf that falls from a riverside tree was cooked inside ancient suns and blown out into the dark. When a river carries a fallen leaf toward the sea, it is carrying starlight in slow motion. When that leaf settles into the mud and becomes part of the next layer of rock, the river is helping to write a sentence in a story that began long before the earth existed. And the rivers that disappear are part of this larger flow as well. The lost rivers of the Sahara still exist as faint shapes beneath the sand. The vanished channels beneath the Mississippi Delta still hold the outlines of older currents. The ghost streams under modern cities still trickle through hidden pipes and forgotten basements, carrying the same atoms that once watered ancient gardens. Nothing is truly gone. The water has only changed address. There is a quiet thought in this, the kind of thought that softens the edges of the day. The atoms in your own body have almost certainly been part of a river at some point in their long history. Some of them may have moved through the Nile when the first cities were rising along its banks. Some may have drifted through the Amazon before the Andes had finished pushing themselves into the sky. Some may have rested in the ice of a glacier for thousands of years before melting and finding their way, by a long path, into the glass of water you drank today. You are, in this gentle sense, part of the river too. So is the listener half a world away who is also drifting toward sleep tonight. So is the sleeping fox curled near a quiet stream, and the tree leaning over a slow bend, and the small stone that the current is shaping by patient touch. We are all moving together through the same long flow, made of the same old atoms, carried by the same old water. The mystery of where rivers truly begin and where they truly end is, in the end, a mystery without edges. Every source has a deeper source. Every mouth opens into a wider sea, and every sea returns to the sky. The question keeps opening outward, the way a river opens into a delta, splitting into smaller and smaller channels until it becomes part of something larger than itself. For tonight, there is no need to follow it any further. The water will keep moving while you sleep. The atoms will keep their slow travels. The river inside you, made of starlight and rain, will carry on its quiet work, and you can rest while it does. And so the long thread of water carries us here, to the quiet end of our wandering. We have followed rivers across deserts that no longer hold them, beneath cities that have forgotten their names, down the slopes of mountains that did not yet exist when the water first began its slow work. We have stood beside the great deltas and listened, in our minds, to the soft hush of mud settling into layers older than language. And now, gently, we let the current carry us towards sleep. Picture the planet from far above, just for a moment, in the soft way a dream might picture it. A blue and white sphere turning slowly in the dark, lit on one side by a kind and distant sun. The continents drift past in muted greens and tans, wrapped in pale ribbons of cloud. And everywhere, threading through every land, the rivers shine. Some are wide and silver in the moonlight. Some are thin as a single strand of hair. Together, they form a faint and beautiful web across the surface of the world, a network older than empires, older than humans, older than most of the rocks they cross. From this gentle height, the rivers look almost still, but you know now that they are always moving. Even as you breathe in slowly, Somewhere, a glacier is releasing one small drop of meltwater into a mountain stream. Even as you breathe out, that drop is finding its way through gravel and moss, joining other drops, growing into a current. By morning, that same water may be miles downstream. By next year, it may be in the sea. By some far, slow century, it may rise again as a cloud and fall again as rain and begin the journey once more. There is something restful in knowing this. The water that flows tonight is the same water that flowed past the first cities, the same water that pooled at the feet of ancient animals, the same water that filled the cupped hands of people whose names we will never know. It has been here all along. It will be here long after. And for a little while, a few drops of it move through us as well, through the quiet rivers of our own bodies, before slipping back out into the world. The mysteries remain, and that is a comfort too. Somewhere beneath the Sahara, the old channels still curve through buried sand, holding their silence. Somewhere under the modern streets, small ghost streams still trickle in the dark. Somewhere in the deep ocean, the canyons of vanished rivers wait at the edges of the continents. No one alive tonight knows every answer. No one ever has. The water keeps its secrets gently and shares them only a little at a time when we are patient enough to look. Let the questions rest beside you now, like smooth stones on a quiet bank. Where did the Nile truly begin? In some forgotten age before the lakes we know today. Why do rivers meander in those slow, perfect curves, as if drawing something they remember? What did the Amazon look like before the Andes rose and turned it around? What words were first spoken along the banks of rivers that no longer exist by people whose voices have softened into silt? These questions do not need answers tonight. They only need a place to sit, and you have given them one. Outside your window, the world is doing what it has always done. Somewhere, rain is falling on a forest. Somewhere, a small creek is moving over rounded stones, making that soft, endless sound that humans have listened to for as long as there have been ears to hear. Somewhere, a great river is pushing its slow weight into the sea, adding one more thin layer of sediment to a delta that will outlast every city now standing. The earth does not hurry. The water does not hurry. There is no need for you to hurry either. Feel how small you are in the kindest possible way. A single quiet life on a single quiet night, held by a planet that has been turning patiently for billions of years. The rivers will keep flowing while you sleep. The deltas will keep growing. The buried channels will keep their long, dark rest. And somewhere far above, the moon will lay its pale light on an ocean that is breathing slowly, in and out, the way you are breathing now. Slower, softer, deeper. Let your thoughts drift like a leaf on a slow current. There is nowhere you need to go. The water knows the way. Subscribe for a brand new Earth topic every night. One tap and something wonderful is waiting for you tomorrow. Sweet dreams.